Before I go into normal usage, I just want to talk about how the system works in general. So as I noted, each battery is communicating with the hub. It is actually sending a signal to the hub. And since it's wireless, it does consume energy. The energy consumption, we've kept it below 10 milliamps. But in order to keep it that low, we wanted to make sure that the frequency of the signal being sent is around 5 seconds. So each one of these batteries will send its status and all its data to the hub every 5 seconds. Each time the hub receives a new status, it will incorporate that data into the aggregated data set. So note that each battery doesn't necessarily communicate at the same time. So since we have 4 batteries, the hub will get a signal every second or so, a little more than a second. And so it will therefore update about every second. If the hub is actually wired via CAN bus, RVC, NEMA 2K, 11-bit CAN, then that update will happen frequently since it's hardwired. But it is important to note that that frequency dictates how often you're going to be seeing changes in your currents or in your voltages. Even though each battery communicates every 5 seconds, the state of charge is calculated a lot more frequently internally. So the state of charge is accurate. That's important to note because if you have a large system of batteries, the state of charge is really dictated by the lowest state of charge battery in a string. So if you're just monitoring the state of charge by a single shunt that's connected to the entire bank, you're not really getting that granular data of, well, what's the state of charge of each individual battery? And that's really important if you want to know the actual time remaining for your system. The one exception to the 5-second rule is that if there's an error or a warning, for example, if you're about to go into a low voltage disconnect or you experience a high current event or short circuit or low temperature or high temperature event, that gets transmitted immediately. So you don't have to wait 5 seconds if it's something that needs to be known immediately. So errors and warnings are always transmitted to the hub immediately, and the hub can react and allow the system to react to whatever error or warning is happening in any individual battery.